Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 1 from summer 2023. This paper is worth 80 marks in total, and this is the first video of 4. It will focus on questions 1 to 6, which account for 20 of these marks. AQA Paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 1. Here is a list of numbers 14, 9, 20, 29, 3, 45 and 33. 1a. Which number in the list is a multiple of 4? So multiples are the times tables for a number. So multiples are going to start with the number itself and then get bigger. Now the largest number in this list is 45. And even though this is a 1 mark question, I'm still going to do a little bit of working out. I'm going to write my 4 times tables out until I get to or past 45. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44 and 48. So I've gone past the largest number in the list. Now I'm going to compare these numbers and see if they appear in the 4 times tables. If they don't, they're not a multiple of 4. So 14 doesn't occur, 9 doesn't, 20 does. So we're going to pop 20 there on our answer line. And then it does say which number, so we expect only 1. However, let's just double check. 29 isn't, 3 isn't, 45 isn't, and 33 isn't. So 20 is our answer for 1 mark for 1A. 1B, which number in the list is a square number? So a square number is the answer that you get when you multiply a number by itself. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. So I've gone past the biggest number in the list, which is 45. So now I just need to see if any of these answers are also in the list. 1 isn't, 4 isn't, 9 is. So 9 must be our square number that's in that list. We can still double check. 20 isn't a square number, 29 isn't, 3 isn't, 45 isn't, and 33 isn't. So it's always worth double checking. 1C, which 2 numbers in the list have a total of 43? So if we put the numbers that are in the list here so we can see them down at the bottom, we're going to be really systematic about this. So if we want them to have a total of 43, we want 2 numbers in this list to add to make 43. So straight away I can discount 45 because if I add that to any of the numbers, it's definitely going to be bigger than 43 because it already is. If I was to use 33, 43 take away 33 is 10. 10 isn't another number in the list, so I can't use 33. If we get to the number 3, 43 take away 3 is 40. 40 is not one of the numbers that's left in the list. We can't use that one. 29, 43, subtract 29. That's 4, so it's 14. 14 is in the list, so we can use the numbers 14 and 29 because they add together to give us 43. 1D, work out the largest number in the list divided by the smallest number in the list. Well, the largest number in the list is 45 and the smallest number in the list is 3. So the sum that we're going to be doing is 45 divided by 3. I'm going to use the bus stop method. You may use a different method, that's absolutely fine. I'm going to write some of my 3 times tables down. So 3 into 4 is 1. remainder 1, 3's into 15, 1, 2, 3, 4, 5, no remainder, so the answer is 15. Question 2a. Here is a square. Use a ruler to measure a side length of the square. Give your answer in millimetres. So this is just a 1 mark question. Now, what's important to note here is it's a square, so it doesn't matter which of these 4 sides we measure, they should all be the same size. So it's just a case of picking one, and then using your ruler, line it up on one of the corners at the end, and then you want to read to the other end of the line, the other end of the side. So this is showing at 5.5 centimetres. I'm just making a note of that there. It says here to give our answer in millimetres. So there are 10 millimetres in every centimetre, so we need to multiply our answer, our measurement, by 10, which tells us that it's 55 millimetres. (2b). Here is a quadrilateral. So a quadrilateral is a 4-sided shape. Wants us to use a protractor to measure the size of the smallest angle. So what we need to recognise here is which is the smallest angle. So this angle here is greater than 90 degrees. This angle here is greater than 90 degrees. This one is less than 90 degrees, but it looks like it's bigger than this one. So this is the angle that we're going to measure. Now, when you're using a protractor, it's really important that this centre mark here goes on the corner where the 2 lines meet that form the angle that you're measuring. And then this 0 line here wants to be flush with the side of the shape, or the side, or the line, I should say, that you're measuring the angle from. And then we're going to read round the outside. So here we go, measures at 50 degrees. We're looking at those numbers on the outside because we made that 0 line there flush with the line that was one of the ones forming the angle, and we've measured around there. So the angle is 50 degrees. Always worth checking that we have measured the smallest angle. So let's just turn it round. Let's pop that centre mark on that 0 line. And then if we were to measure the angle for this line and continue that line, we can see it goes past 80. So we were right in our assumption that this would be the smallest angle to measure. Okay, 2c. A different quadrilateral is drawn on a centimetre grid. So each of these squares has sides of a centimetre. By counting squares, work out the area of the quadrilateral. So the area is the space inside the shape. So we're going to count all of those centimetre squares inside that shape. And I'm going to number them to make my life a little bit easier. So I'm going to start with the whole squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 whole squares, but then we have to deal with these half squares. And we have to remember that 2 halves will make a whole. So these 2 will make another one, which takes us to 13. These 2 will make another whole square, which takes us to 14. And then these 2 will make another whole square, which takes us to 15. So it is 15 centimetres squared. (2d). One side of a rectangle is drawn on this centimetre grid. So it's a centimetre grid. So what we can do is 1, 2, 3, 4, 5, 6, 7. So that length of the rectangle is 7 centimetres. Complete the rectangle so that it has a perimeter of 20 centimetres. So perimeter is all the way around the outside of a rectangle. So if we know that this length here is 7 centimetres, this length here must also be 7 centimetres because of the properties of a rectangle. They're parallel and exactly the same size. What we need to figure out is how far the distances between them, so what the width of the rectangle is. So if these two longer lengths are 7 centimetres, 7 plus 7 is 14. We've got a total perimeter of 20, so 20 subtract 14 is 6. So these two sides must add to 6, which means they must be 3 centimetres each because they are equal. So that tells us how far up we're going to draw the width of our rectangle. So you're going to get your ruler. I would recommend drawing this in pencil so that if you make a mistake you can rub it out and then it's nice and clear what your answer is. We're going to draw 3 centimetres up and 7 centimetres across to complete that rectangle. Question 3a. Work out -4 multiplied by -3. So we're doing a multiplication sum here. The brackets don't make any difference to our sum. They're just highlighting the fact that they're both negative values at this instance. So if we're doing a negative multiplied by a negative, the signs are the same. So we're going to get a positive answer. And then we're going to do 4 multiplied by 3, which is 12. So our answer is positive 12. But we don't need to write the positive symbol, we can just write 12. (3b). Work out 6 multiplied by -5. This time it's a positive multiplied by a negative, so the signs are different, so we're going to get a negative answer. 6 multiplied by 5 is 30. This time we do need to write that negative sign to let them know that our answer is negative. (3c). Work out -8 to the power of 2. So that's -8 squared. That power of 2 means we're multiplying -8 by itself twice. So we're doing a negative times a negative, which means we're going to get a positive answer because the signs are the same. 8 times 8 is 64, but we don't need to write that positive sign in our answer, so we're just going to write an answer of 64. And then finally 3d, work out 10 to the power of 3 or 10 cubed. So that power of 3 means we're multiplying 10 by itself 3 times. 10 times 10 is 100, and then timesing it by that third 10 gets us to 1000. 1 mark for each of those questions. Question 4. Write 18 out of 30 as a fraction in its simplest form. So if we're writing a fraction, the total goes on the bottom as our denominator. So if it's 18 out of 30, then 30 must be our total. So 30 is our denominator. And then the 18 we write as our numerator. Now we need to make sure our fraction is in its simplest form. So what I know is that 18 and 30 are both in the 6 times tables. So if I do 18 divided by 6, I get 3. And if I do 30 divided by 6, I get 5. 3 and 5 don't have a common factor other than 1 right now. So 3 over 5 or 3/5 is our answer. Now you may have not spotted to divide by 6 straight away. You might have divided by 2 or divided by 3. That's fine, just keep going till you get to the simplest form for that fraction. Question 5. At a shop, the normal price of 1 pen is 24 pence. The normal price of 1 calculator is £7. The shop has these special offers. For pens, half of the normal price. For calculators, £1.50 less than the normal price. Work out the total price of 5 pens and 1 calculator using the special offers. So we need to work out the cost of a pen and a calculator with those offers taken into account. So if pens are half the normal price is 24 pence. So So we're going to do 24 divided by 2 to half it. So each pen is going to cost us 12 pence. We want 5 pence, so 5 times 12 gives us a total of 60 pence for the number of pens that we want. Now we need to find the cost of a calculator given that special offer here. So calculators are normally £7, but they're going to be £1.50 less. So I'm going to write £1.50 and then subtract it from that normal price. So 0 subtract 0 is 0. I'm going to borrow, change the 7 to a 6 and make that 0 into a 10. So that 10 subtract 5 gives me 5. And then 6 subtract 1 gives me 5. So it's going to cost me £5.50 for one calculator. I want the total price of 5 pens and one calculator. So I'm going to add 60 and £5.50. Remembering that 60 is in pence and the £5.50 is written in pounds. So when I set it up in whatever method I'm going to use for this, I need to make sure that I'm using them in the same format, so they're both in decimals for pounds or they're both in pence. This time I'm adding, because we're totaling. 0 plus 0, 5 plus 6 is 11, 5 plus 1 is 6, so the total cost is £6 and 10 pence for 4 marks. Question 6a. Write 3 2/5 as an improper fraction. It's currently written as a mixed number. We've got a whole number part and a fractional part, but they've asked us to write it as an improper fraction, so we're going to convert that now. So we multiply the whole number part by the denominator. So 3 times 5 gives us 15, which means the whole number part is worth 15 parts. And then we add the 2 parts that we have on the top there as well. So 15 plus 2 is 17 parts as our numerator, and the denominator stays the same. So we write 5 as the denominator for 1 mark. It doesn't ask us to simplify or anything, because if we did, we'd just be making it into a mixed number again. 6b, write 0.19 as a fraction. So we're writing a fraction. It doesn't ask us to simplify it, so I'm writing it straight on my answer line here. So 0.19, the 19 becomes our numerator on the top of the fraction, and we have 2 decimal places here. We have tenths and hundredths. So we're going to write this as a fraction out of 100. So our denominator will be 100 on the bottom there for 1 mark.